Okay, hi guys. So in this lecture, we'll be continuing on seeing the conversion of one organic compound into another using various reagents which we discussed in the past set of lectures. Okay, suppose you have a toluene and you have a succinic anhydride. Okay, so and you are reacting with succinic anhydride in presence of ElCl3. So you will get a product A. Then you are reacting the product A with zinc amalgam in presence of HCl. You get a product B, and then HCl2 and then ElCl3. So you have to determine what all products would be formed. So this is the structure of succinic anhydride. Okay, so what will happen is electrophilic substitution reaction will take place, in which on reaction with AlCl3, the O will give its electron to the unfilled orbital or empty orbital or empty d orbital of aluminium, hence will form a positive charge here, which will be stable because of the formation of our IIT like cation. Okay, and hence the electrophile will be attacking on this carbon atom to form something like this, and we get 1 2 3 1 2 3 and double bond OH group here. Okay, then on reaction with the zinc amalgam and HCl, reduction will take place, in which this oxygen C double bond O will be reduced to CH2. Okay, hence it will act as a reducing agent. We can also use other good reducing agents, but for the timing we are using zinc amalgam. Okay, so we'll get something like this. Then we are reacting with SOCl2. What is the structure of HOCl2? You have S double bond O, Cl and Cl. This lone pair of electron will attack on sulfur atom, form positive charge here. Chlorine atom will detach itself again, which will add itself to H plus again. O, the positive charge on O will be neutralized, hence then again the lone pair of oxygen will again act on this sulfur atom, will evolve the SO2 gas. Cl minus will be formed, and here carbocation will be formed. This benzene ring will act as a nucleophile. Electrophilic substitution reaction will take place, and this carbon will act on this positively charged carbon atom here. Why? Because of the formation of 1 2 3 4 5 6 member stable ring. Okay, 6 member ring formation will take place, something like this, and we will have O double bond O here. And again on reaction with AlCl3, let me say we are also providing some acidic medium. What will happen is this double bond would be actually broken up. Okay, and we'll get OH on one side and H on one side. So this is just for the understanding sake. Exactly, the O electrons will act on unfilled orbitals or empty d orbitals of aluminium, and we'll get O minus, rather O plus Al minus Cl3, and we'll get the bond detached from this. So we'll get a positive charge here. OH will attack on this carbon. Okay, or rather you can say that this is forming a positive charge. So what will the reaction after this? Let's say after this we are heating it also. Okay, so what would be the product form? So I think elimination reaction will take place, in which this the OH formed after again on because water is also there, and positive charge will be formed on this carbocation, because this O has withdrawn its bond electron from this carbon atom and getting itself neutralized, and because it was previously attached to Al minus Cl3, again it will do is we will have water molecule which will actually extract H plus from this, thereby forming a bond or a double bond with this uh, with this carbon atom. Hence there will be a double bond also, and the leaving group, what it will do is the leaving group will again cause a, so for the clearing purpose I'll just show it again. We will have something like this. Okay, O AlCl3 double bond is there. Okay, it will take one H plus from the water molecule to form to form a positive charge here, and at the same time OH minus will be attacking again on this carbon, so we will get something like this. Okay, so this is some type of unorthodox reaction, but this question was actually asked in some previous year examinations, in which you have to come up with a new mechanism as to derive the product. So this is a slightly unorthodox product. Okay, but this was a real example which was asked in some previous year Olympiad or J level examination. Okay, so let us actually move on to the preparation of DDT. Next topic is preparation of DDT. So not a topic exactly, we are just taking an example with a reaction. So we have something like this. Okay, and we are passing on 2 moles of chlorobenzene, and in H2SO4 what will be getting? We'll be getting something like this product. Okay, this is called DDT. Okay, so how does the reaction take place? We have CCl3 and H. It takes plus H plus from the H2SO4 and converts itself into a positive charge. Okay, and now the chlorobenzene will act on this electrophile. Okay, and we'll get something like and other CH. This is carbon atom, so we'll get something like CH. This will take the bond and we'll get CCl3. Now again what will happen is this OH will again act with H plus because of the acidic medium provided by the H2SO4. We'll get a double bond here. We'll get a partial positive charge here. Again the benzene to the second mole will again attack on this electrophile, and we'll get something like this. It will be taking away its bond electrons from the neighboring carbon atom. We'll get something like CCl3 here, Cl here. So DDT is formed. Okay, now let us take another example. So another preparation step, in which, or rather set of reactions which can happen with the V2O5. So reaction with V2O5. Okay, and we will also see reaction with K1O4. What is the difference we get when we reacted with K2O5 and K1O4. Okay, so this is a benzene ring. When we react this with V2O5 in 500 degrees Celsius, we will get something like anhydride. Okay, and when we reacted with KMnO4, no reaction takes place. Secondly, if we react this compound with again V2O5 in 500 degrees Celsius, we will get something like this product. Okay, and again anhydride, and we reacted with KMnO4, we get something like 2 dicarboxylic acids. Okay, what happens when we react this compound NO2 substituted here with the V2O5 at 500 degrees Celsius, anhydride would be formed on this ring. Okay, so we will get something like NO2 would be retained here and anhydride would be formed on this ring. Okay, and if we reacted with KMnO4, what will happen? Again this ring would be converting itself into carboxylic acid, dicarboxylic acid substituted to benzene ring. So we'll get something like this. OH. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing the carbene. Okay, formation of carbene, reaction of carbene, etc. Okay, so till then, good luck and goodbye.